Hey, my name is Dwayne, and this is my GED Intermediate Math series. This is lesson 4, which is on finding the greatest common factor and least common multiple. So, greatest common factor is, we use greatest common factor to arrange things into groups. And factor, unfact. So we're looking at greatest common factors, meaning we're going to look at two different numbers, and we're going to try to find the biggest. The reason we do this is because this will help us figure out how to arrange things in groups. So let's say you are a farmer and you have an orchard, and you harvested 20 apples and 36 oranges. Right, 20 apples and 36 oranges. Apples and oranges are about the same size, so you would love to buy one size box that you can put apples or oranges into. Right. The problem is, how big does your box have to be in order to fit all these apples and oranges equally in equal groups without having anything left over? Right. So we're gonna have to lean on greatest common factor. So what we do is we write our two numbers, 20 and 36. And then what we do is we brainstorm all the factors those numbers have, right? So the first factor is always 1, because 1 times the number is always itself. So for 20, it'd be 1 and 20, right? And then next we count our way up. So next is 2. Does 2 go into 20? It does. So that'd be 2 times 10. All right, 3 does not go into 20. 4 does go into 20. So 4 times 5 equals 20. All right, there is nothing between 4 and 5. Rather, there aren't any whole numbers between 4 and 5, so we can stop right there. These are all of the factors of 20. Now, let's look at 36. All right, so the first one is always 1 and 36. 2 goes into 36, so that's 2 times 18. 3 goes into 36 12 times. 4 and 9. And then 5 does not go into 36. 6 does. So 6 times 6 is 36. Since our last factors were 6 and 6, which are literally the same number, that means there are no other factors of 36. If we keep counting up, we'll just reach the ones that we already have. So these are all of our factors of 36. We're going to find the biggest factor that they have in common. So first I'm just going to look at what factors they have in common. We got 1, 1, 2, 2, 4, 4. That's it. Yep. So 5, 10, and 20 we do not see over here. All right. Now we're going to find the biggest one that we have in common, and it is going to be 4. All right. So what that tells us is if we buy a box that will hold 4 apples or 4 oranges, we can put all of these apples and oranges into these boxes with no apples or oranges left over and no wasted space, right? If we do apples, it'd be 5 groups of 4 for apples. And then for oranges, it would be 9 groups of, I'll write that over here. It'd be 9 groups of 4. So 9 boxes filled with 4 oranges each. Cool. So that is greatest common factor, right? You just find all the factors of the two numbers you're comparing, and you find the largest factor that they both have. Cool. So the other half of this lesson is least common multiple. So we use least common multiple to figure out when 2 things will happen at the same time, or to figure out how many things we need to purchase in order to have enough. So let me give you an example. So here's an example where we might use common multiple. Let's say we have a timer that goes off every 4 seconds. Automatically, it just every 4 seconds, bam, it goes off. Bam, it goes off. And let's say we have another timer that goes off every 7 seconds. Right? Again, automatically, all by itself. And something while we're being driven crazy by all these timers going off, something we might wonder is when will both of these timers go off at the same time, right? So what we do is we we figure out its multiples, right? So multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, and I'm kind of running out of space, but that could be enough. We can probably stop there. Next, we're going to do 7. So again, we're skip counting by 7s. So 7, 14, 21, 28, 35, 42, and this is getting big. We can stop there, right? Now we want the least multiple. So we're going to find all the multiples that they have in, well, actually, there should be only one multiple they have in common. And it looks like the one that they have in common is 28. Okay, if I had made my list longer, eventually we would have found other multiples that we share, that are shared between 4 and 7. But we're looking for the least common multiple, so that's always going to be the smallest one, right? So in this case, it is 28. So at 28 seconds, the 4-second timer and the 7-second timer will both go off at the same time, right? Now, there's some tricks we can use to make this process a little easier, right? Because I was going off vibes for when we stopped listing out multiples, because we could list out multiples forever. How do we know exactly when to stop? Well, here's a little trick. Often, not always, but often, the least common multiple between two numbers is is the product of those two factors. So if you times 4 times 7, you get 28, which happens to be the answer for this problem. Okay? However, you always want to double check. You always want to write out all these multiples, because it's possible that the least common multiple actually happens earlier than that. But I always recommend starting off by just multiplying those two numbers together, because we know that this right here is a common multiple between 4 and 7, which means that when we're making our lists, we can stop once we get to 28, or once we go past 28. Actually, we can stop when we get to 28, because the answer cannot be anything bigger than 28. 28 is the absolute maximum the answer could be, right? So really, we didn't have to do 32. We didn't have to do 35 and 42. If I had started off by multiplying these two numbers, I would have known to stop once I hit 28, right? So that is a common multiple. Let me give you another example. So for our next example, let's look at 4 and 12. All right, so let's say that there's a train that stops every 4 stations, and then there's another train that stops every 12 stations. When will those two trains stop at the same station at the same time? We're going to have to do least common multiple to figure that out. So we got 4 and 12. First thing we're going to do is multiply those together so we know the maximum our answer can be. 4 times 12 is 48. So when I'm making my multiples list, I will stop at 48. And actually for 4, I'm probably going to stop. We're going to stop at 48. All right. Let's start making our list. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Okay, cool. So I know 48 is the maximum the answer could be, so I'm going to stop right there. All right, and then we'll do 12. So that is, where is my O? All right, 12, 24, 36, and 48, so I can stop right there. Right? So I know both these numbers have 48 in common, right? Because that's what we said at the very beginning. They have to have 48 in common. But do they have another multiple in common? What is the least common multiple? And actually, I see they have 36 in common, they've got 24 in common, and they have 12 in common. So which one's the least common multiple? Well, it's the smallest one. So in this case, that would be 12, right? At the 12th station, both these trains will meet. or rather, both these trains will stop at the 12th station. So our answer is going to be 12. Cool. So that is least common multiple, right? And so in class we have you. And yeah, if you need more practice on this, let me know, and I can get you a lesson on IXL on this. But otherwise, thanks for watching.